I am Rahulas and today I am going to say about thermodynamics. What is thermodynamics? Thermodynamics is a branch of physics that deals with the heat, work, and temperature and their relation to energy, entropy, and the physical properties of matter and radiation. The behavior of these quantities is governed by the four laws of thermodynamics, which convey a quantitative description using measurable macroscopic physical quantities. There are so many branches of thermodynamics like classical thermodynamics, thermodynamics, chemical thermodynamics, and equilibrium thermodynamics. Classical thermodynamics. In classical thermodynamics, the behavior of matter is analyzed with a macroscopic approach. Units such as temperature and pressure are taken into consideration, which helps the individuals calculate other properties and predict the characteristics of matter undergoing process. Statistical thermodynamics. In statistical thermodynamics, every molecule is under spotlight. That is, properties of every molecule and how they interact are taken into consideration to characterize the behavior of a group of molecules. Chemical thermodynamics. Chemical thermodynamics is the study of how work and heat relate to each other in chemical reactions and changes of states. Equilibrium thermodynamics. Equilibrium thermodynamics is the study of transformation of energy and matter as they approach the state of equilibrium. Terms used in thermodynamics. System. A thermodynamic system is a specific portion of matter with a definite boundary on which our attention is focused. Enthalpy. Enthalpy is the measurement of energy in the thermodynamic system. Mathematically, the enthalpy H is equal to E plus PV. H equals to the sum of internal energy E and the product of the pressure and volume V of the system. Entropy. The entropy is a thermodynamic quantity whose values depends on physical quantity or condition of a system. In other words, it is a thermodynamic function used to measure the randomness or disorder. Thermodynamic properties. Thermodynamic properties are defined as characteristic properties of a system capable of specifying the system state. Thermodynamic properties may be extensive or intensive. Intensive properties are properties that do not depend on the quantity of matter. Pressure and temperature are intensive properties. In the case of extensive properties, their value depends on mass of system, volume, energy, and enthalpy are extensive properties. Thermodynamics laws define the fundamental physical quantities like energy, temperature, and entropy that characterize thermodynamic systems at thermal equilibrium. These thermodynamics laws represent how these quantities behave under various circumstances. There are four laws of thermodynamics are given. Zeroth law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. Zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two bodies are individually in equilibrium with a separate third body, then the first two bodies are also in thermal equilibrium with each other. This means that if system A is in thermal equilibrium with system C and system B is also in equilibrium with system C, then system A and B are also in thermal equilibrium. First law of thermodynamics, also known as the law of conservation of energy, states that energy neither can be created nor be destroyed, but it can be changed from one form to another. The first law of thermodynamics may seem abstract, but we will get clearer idea if we take a look with few examples. First, the plants convert the radiant energy of sunlight to chemical energy through photosynthesis. We eat the plants and convert the chemical energy into kinetic energy while we swim, walk, breathe, and scroll this page. Second law of thermodynamics states that if the entropy in an isolated system always increases, any isolated system spontaneously evolves towards thermal equilibrium. the state of maximum entropy of the system. If a room is not tidied or clean, it inevitably becomes more messy and disorderly with time. When the room is clean, it entropy decreases, but the effort to clean it has resulted in increased entropy outside the room exceeding the entropy lost. Third law of thermodynamics states that entropy of a system approaches at constant value as the temperature approaches absolute zero. The entropy of a pure system, crystalline substance at absolute temperature is zero. This statement holds true if perfect crystal has only one state with minimum energy. Thermodynamics examples in daily life. Whether we are sitting in an air conditioner room or traveling in any vehicle, the applications of thermodynamics is everywhere. We have listed a few of these applications below. Different types of vehicles such as planes, trucks, and ships work on the basis of second law of thermodynamics. The three modes of heat transfer on the basis of thermodynamics. The heat transfer concepts are widely used in radiators, heaters, and coolers. The thermodynamics is involved in the study of different types of power plants, such as nuclear power plants, thermal power plants.